Hi, everybody. Josh Byerly here in Mission Control, Houston. I'm sure most everybody recognizes the person that's sitting beside me, but this is Peggy Whitson, astronaut. Let's see, record holder, former space station commander, former chief of the astronaut office. Peggy's done quite a lot of things. I've spent many hours on a plane to Kazakhstan with Peggy, so we've known each other for a while. But Peggy, I can't really think of anybody probably more appropriate to talk about women in science like we've been doing all this week than you, because a lot of people don't realize before you ever even became an astronaut, you had a long career as a scientist, a researcher, a professor. She's got a bachelor's of science degree in biology and chemistry. She's got a PhD in biochemistry. So talk about these anniversaries we've been mentioning with Valentina Tereshkova and Sally Ride and how that sort of led to women in science. What are your thoughts on that as somebody who studied a lot in that field?
Well, I think I became interested in science just because that was my natural interest. I was
Yeah.
very interested in high school in biology. And when I went to college, I took a lot of classes in chemistry and ended up double majoring in biology and chemistry. But I think the role, particularly for Sally Ride in my career, was the fact that in 1978, when I graduated from high school, that year was the year they picked the first female
Right.
astronauts. So there was a whole class of females selected that year, and it was very important to me in that I had wanted to be an astronaut before, but at that point it became more of a goal, something that I thought it was achievable, and from that point on, that's what I wanted to do.
Yeah.
Luckily, I had no idea how difficult it would be, or how much effort and time it would take to
Yeah.
actually make that goal a reality. But I was lucky enough to be selected many years later.
Yeah.
And during the course of that time, I think one thing that I always advise young people is, in the pursuit of a goal like that, you have to be having fun along the way.
Yeah.
It's especially something like being an astronaut. It's not very many people that get lucky enough to be selected because we have just literally thousands of people to select from. And so, in order for us to be effective, you just have to have fun along the way and doing what you're doing and being a great professional at whatever job it is. So.
We ask people all the time, especially the astronauts, did you start out wanting to become an astronaut, or did you go into a field that you were passionate about and it sort of led to it? And it sounds like you're kind of saying sort of both. I mean, you kind of knew the end goal, but you love biology and chemistry so much that it sort of led to where you are.
Absolutely. I do think it's important that you can't just become an astronaut by checking boxes.
Yeah.
You've got to pursue something with a passion, and that passion will make you stand out amongst your peers, and that's a very important thing. Also, for the having served on the last three selection boards, it's really important to have a diversity of different experiences because when we go into space, that's just another different experience that we have to
Yeah.
be able to cope with. So, being able to work in different environments and being able to achieve things in awkward situations or
Hmm.
unusual or
Yeah.
not common situations is an important aspect in who we try and select to be an astronaut as well.
So you mentioned being on the last astronaut selection boards. We just announced the new class that we're taking a look at your launch here on screen. But the last class that we had, it was notable and it was in the news because it was exactly half and half women, half men. Is that, I mean, what are your thoughts on that? Is that just sort of a normal thing now, or is that still sort of a landmark event?
I think it was a little bit of a landmark event. It was not an intention that we were going
Yeah.
to select a group that was half and half, and I think it speaks to the caliber of the folks that we were interviewing, both males and females, but that we ended up with
Yeah.
half and half was it was really actually coincidental. Obviously we want to have a diverse group of people, but the exact number just happened to be
Just
a
happened to be,
coincidence.
and their backgrounds are all over the place. I mean,
Yeah.
it's really, you say diverse, it really is. I mean, they come from military science, all sorts of disciplines of science. I mean,
Hmm.
I think it's cool whenever kids ask, how can I become an astronaut? It really is all over the place in terms of what you can go into and ultimately end up, flying in space.
Yes, absolutely. I think the important thing is any field, math, science, or engineering, is applicable to what we do in space.
Yeah.
And having that operational bent, like the military folks have to offer, is another category that works really well in our core.
Yeah.
But I think that being the jack of all trades, being able to pick up all those pieces that you might not necessarily have had a lot of professional training in is
Yeah.
important for the future of the astronaut once they are selected.
Let's talk about your time on board the station. You were Expedition 5 and 16, so a few years apart. Was it radically different, the first time you went up there versus the second time, or was it just, I'm sure it was bigger, the complex was bigger, but what was life on board like the two different times?
Actually, the complex hadn't changed that much because right after my Expedition 5, we had the Columbia accident,
Yeah,
and so we weren't doing a lot of assembly.
a lot of building, yeah.
So when I arrived, we were just beginning on my second flight. We were just beginning the expansion, and
Yeah.
so during that time, during Expedition 16, we increased the internal volume of the station about 45%. So we had done some assembly on the external parts of the station, but the parts where the crew lived in hadn't changed that much
Yeah.
since I'd been there previously. So it was a very exciting time to be involved in that growth of the station.
Well, one person that brought up a pretty sizable piece of the International Space Station was Pam Melroy during STS-120. They brought up Harmony. You were there. We're taking a look at the this famous picture of the greeting between you two. We're talking about women in science and women in spaceflight. Talk about that moment for a second, that you have, the two commanders sort of united across this hatch.
Yeah, that was very special for us to actually have
Yeah.
that time together. Pam STS 120 was supposed to arrive about a month
Mm-hmm.
before my launch, and so I wasn't actually supposed to overlap with her and her mission. And so it was just very coincidental that we both happened to be commanders on
Yeah.
board the station and on the shuttle at the same time, and be on orbit as commanders at the same time. It's very special for us, obviously.
So space station and science, talk about the importance of it and what it sort of offers from a big picture. Why do we do this?
Well, the International Space Station is a unique, and it is that it's a unique laboratory in space, and it offers an environment that doesn't have gravity,
Mm.
and that is the variable of most of the experiments that occur on board the International Space Station. Because we could do all of these experiments on the ground, but the variable, the unique thing about
Yeah.
the experiments that we do up there is no gravity, and that changes some of the physical properties of different reactions or interactions. Like for crystallization, you don't have those effects of gravity pulling and changing the way things actually go together. And those crystals might be biological crystals, or they could be superconductor crystals, or
Yeah.
zeolite crystals. They could be anything. And those physical parameters, the lack of gravity, offers us a unique look at some of those characteristics of something that we understand pretty well on Earth, but once we put it in space, it's altered
Yeah.
because of that
Changes.
lack of gravity. One of the more exciting experiments that I did was looking at, and I like all the experiments, but I like the experiments that involve a little more hands-on
Mm-hmm.
activity, just because it gets me a little more involved, makes me feel a little more
Like the scientist.
the scientist. Um, but was looking at a colloidal suspension of iron that we had an electromagnetic field around.
Yeah.
And that colloidal suspension, when you put it in an so it's kind of like a super thick liquid, and then you put it in the electromagnetic field, and it would form a solid structure.
Yeah.
And the thought is that you could potentially use this in suspension bridges or shock absorbers or something.
For like earthquakes and
Yes,
yeah.
exactly. So it has some potential benefits there, and they're just trying to understand the physics of
Mhm.
how you form these structures. Well, one day, because my eyes were getting a little old, instead of putting in the 20 hertz required on the electromagnetic field, I didn't see the decimal place, so I put in 2.0. And they saw this structure, instead of forming a solid structure, formed this waveform structure that was
Yeah.
moving. And they hadn't seen that on Earth. And so, interestingly, a lot of the research that we do on board station, the benefits of it have to do with that time of being on board. Because once we saw that it did something different than it did on Earth, then the investigators went back and looked at it at a different frequency as well. And that's going to be the benefits of having that long duration capability on board. And we're going to be asking, I wonder why I did that. That is when you actually have the biggest discoveries, or when we see that difference. And that's just like in the laboratories here on Earth. I wonder why it did that. That's when you find the discoveries.
Sometimes
And
by
having
happy
the,
accident, right?
exactly, and having the time to actually go and examine that. On many of our previous missions on shuttle and then even some sounding rocket things, they're all very quick. And you don't have that time to really explore what that lack of gravity is doing in your experiment. And so our investigators are focusing on that. And of course, being a biochemist, I also like all the physiological studies
Yeah.
because for me, that is our primary focus of understanding how we're going to get further, get to the next step, go on to live on the moon or go on to Mars, go to these different places. We need to understand that physiology completely. And, you know, the ocular experiment that we're doing now is a really
Yeah.
good example of us having flown in space for a long time and then only recently discovered that, hey,
This
there
is,
is
yeah.
another factor that's going on here that we need to better understand in order to make sure that, you know, people are not going to have permanent vision damage, and see if we can understand why it happens
Why is happening?
and prevent it, obviously.
So you ready to go back?
Absolutely. And a heartbeat.
I knew that was going to be the answer. Peggy, thank you so much. It's always good to talk to you.
No problem. It was a
All right.
lot of fun.
If you'd like to learn more about Peggy's past flights, Expedition 5, Expedition 16, or what the crew is doing currently on Expedition 36, it's hard to say that number. It's just, they go by so fast. Just log on to the NASA website at www.nasa.gov/station. Take a look at what the crew is up to and all the different research and science experiments that they work on each and every day. Thanks again, Peggy.
Thank you.